You've learned about using sequencing in your programs to make sure that objects in your program do exactly what you want them to do. But sometimes a decision needs to be made. Sometimes you want your program to choose one instruction if a certain condition is met, and to choose or select a different instruction if it's not. This logic structure is known as selection, and in this lesson, you'll learn how to use it in your programming. We briefly covered the topic of selection in Unit 1. We briefly touched on it. You had a chance to see an example of selection. So you know that it is one of the three major algorithmic structures that we are going to focus on in this course. Of course, first there was sequencing, and you just spent the previous two lessons learning how to develop an effective sequence of instructions to achieve your goal. And after this, we'll talk about iteration, repeating through a process. But for now, we're on step 2, or structure 2, which is selection. And we're going to cover that over the next two lessons. To focus back in on selection, let's just jog our memories about what we learned in the past about it. We already said, based on your understanding of sequencing, that typically when you come to, when you start at line 1 of a computer program, in sequencing, here's this arrow. We know that an arrow tells us that we move directly on to step 2. However, sometimes there is actually a decision point before moving on to the next step. Something has to be checked. A condition needs to be checked to find out if we are actually ready to move on or if we really need to do something else. So this other arrow over here is showing us that based on whatever the condition is, if the condition is a certain way, let's just say if the condition is true, we will move on to step 2. But if the condition is not true, skip step 2 altogether and move on to instruction 3. All right, so selection allows this decision making, allows your program to evaluate some condition and select which instruction to follow based on the state of that condition. Some common selection statements, the way that you might see them in programming. You might see if statements, you might see if-else statements, or you might see either one of those types of statements combined with comparison. And we'll talk in detail about each of these three. Let's take a look first at if statements. These are the most basic and common example of a selection statement. Let's take a look at this example. If it is raining, then you should carry your umbrella. And all we need to do to evaluate whether or not to bring the umbrella is it raining? Yes or no, true or false. So there's a criteria, that's the is it raining, that needs to be met in order for the statement to be executed. Criteria, we might even say a condition. So only when that criteria or condition is met will the then portion be carried out. Right? Pretty simple, makes sense. Let's take a look at if statements the way that you might see them in AP style pseudocode, in the College Board's pseudocode. The example on the left is straight from the reference sheet. If you recall, we talked about how on the exam you will be allowed access to this reference sheet. It'll be in your booklet, and it will have all kinds of reminders about what certain types of structures mean. And you actually have this reminder right here. It actually uses the word selection. You'll see that to remind you of what selection is. And this is what you'll see. If some condition, okay, and I'm just going to underline that word condition because we're going to use that word a lot. If there is a particular condition, in the case of our previous example, if it's raining, the condition is it's raining. Then, and notice the word then does not show up in here, right? There's no then. The way that they indicate this is these curly braces right here. That's the implied then, okay? So we don't see the word, but if the condition, then you will do whatever is inside those curly braces. All right, and that's pretty common in text-based pseudocode. And then you can see how the actual visual representation of this, they have the rounded rectangle if, and then they have the oval condition, and then the block of statements is clearly inside that loop. So you can see how they give that. And they even tell you over here, they tell you what it does. Okay, so you will have this example to use on the exam if you ever forget what selection is. But I'm hoping that by the time we're done with this lesson and with this course, you will not even need to be reminded. So let's just take a quick look over here. On the right-hand side, I just included an example of what an if statement might look like in Scratch. So this example, you have to picture the cat walking towards a big black rectangle. All right, and the rectangle is to the right. So if the cat ends up touching that color, touching the rectangle, then they do include the word then right there. AP style pseudocode does not, but Scratch does. If it's touching the black rectangle, then it's actually going to point itself in the opposite direction and move away 10 steps. In other words, that's simulating as if it's running into it and bouncing off. All right, so if, and this is the condition, conditions in Scratch, remember, are those hexagon shapes. If that condition is met, then it's going to execute that little sequence. All right, sometimes we want to go a little bit beyond just telling the sprite what to do if something is true. A lot of times we really need to include what to do if it's not true as well, or false, whatever the case may be, whatever the condition is. If the condition is met, we do want to tell what happens, but if the condition is not met, we may want to specify which instructions to follow in that case. So here we have our good old example of whether or not it is raining outside. So if it is raining, you should carry an umbrella, but if it is not raining, you should be glad. That will be me. All right, so we also want to look at some examples here for what you might see on the reference sheet and how we might implement this in Scratch. So this if-else is also included on your reference sheet, and this is what you will see. So notice, here's our if, and here's the condition. So this is the only condition that is set. Sorry, I just crossed it out, but that's the only condition. So here, inside these two curly braces, we have the first block statement of what to do if that condition is met. Then, right underneath, we've got this else, all right? And again, a couple curly braces here, and it's letting us know this is the statement or series of statements to follow if the condition is not met. All right, and here you can see it looks a lot like the if block, but it just includes this else. All right, and again, just one condition over here. And if you're ever at a loss on the exam for refreshing your memory on what an if-else statement does, you've got all of the explanation you need right over here. All right, so looking at Scratch, this example really comes from the cat trying to get through a maze, of having drawn a maze, a series of black rectangles on the screen, and we don't want the cat to be able to walk through walls. And so this is some behavior to limit the ability to walk through the black rectangles. So we already looked at this top section here. We said that this kind of simulates the sprite acting as if it's bouncing off the rectangle, but it also tells what to do if you're not at the rectangle, which means just carry on when the right arrow is pressed, just carry on moving towards the right 10 steps every time. All right, so it's a little bit more clear, a little bit more complete of an instruction because the sprite knows what to do no matter what. So now we have finally gotten to statements with comparison. All right, and these are if or if-else statements. And we said before that the condition that we used in both of the previous examples was, is it raining? All right, and that's a pretty simple condition to evaluate. But sometimes your condition actually needs to be based on more than one thing, or there's more than one possibility. All right, so here's an example. We know that the age that you must be to vote in a US election is 18. And so if you were going to write a program that was going to ask the user, try to find out whether or not the user is able to vote, this is how you might do it. You might want to start off by checking to see, are you older than 18? And if you are, of course, you're eligible to vote. But there are more possibilities than that, because they might not be older than 18, they might be exactly 18. They might have just had a birthday. We don't know. And if that's the case, even if you just turned 18 yesterday, or if today is your birthday, you are still eligible to vote. So then you would still say yes. However, the third possibility exists that you have not reached the age of 18 yet. And in that case, you are not eligible. All right. That just seems kind of complicated, right? It's three, if you think of making this program in Scratch, you would have to ask 3 different questions, right? And that's a lot of code. And we don't necessarily want to do that. So to simplify it, what we do over here is we ask the same question. Well, actually we don't. Sorry, we ask a more generic question. All right, we ask a question that has more flexibility in the answer. So we'll ask, what is your age? And the user will type in some number. And all we have to do now, because of course we know we can save that answer, is we have to compare the answer to 18. This has now become our condition. The condition that needs to be met to be eligible to vote is that you need to be either 18 years old or older. And you probably recognize this symbol, we're going to talk about these more, as a way to establish both things, okay? So you can be 18 or you can be older than 18. But if you don't meet that condition, if you are not greater than or equal to 18, then you're not. It's noticeably less code. In Scratch, it would be noticeably less blocks, and it also allows for the user to just enter their age instead of answering a whole bunch of yes or no questions about their age. So it's much more succinct and straightforward. All right, so some statements with comparison. This is not directly from the AP reference sheet. It's just sort of a text-based pseudocode version of an if statement, but this is obviously, you can probably just read this and know what it's doing. It's trying to determine whether a number is positive or, I won't say negative, positive or not positive. All right. And the condition that needs to be met for a number to be positive, here's the condition right here. It's inside the parentheses. The condition is that n, presumably that means age, is greater than 0. Right? Because we know numbers greater than 0, no matter what they are, decimals, fractions, or integers, are going to be positive, right? So that's an example of something that you might see where the condition is created using comparison, all right? And that's right here. The condition was created by comparing the variable to 0 and determining whether or not it's greater. So over on the right, we have this same type of thing that we say in Scratch. So I've used that term operator a couple times, and that is actually an entire palette in the Scratch environment, and it's green. So operators are green, and probably from this day on you will associate operators with the color green, but we have all sorts of operators that we can use. And if we were to create a variable called n, which isn't quite as informative a variable name, so you should name your variables according to what they are, not by a letter, but we can compare n to 0 and find out if it is indeed greater than. All right, and then we can do exactly the same. Remember, this is the display. You will see display on the AP exam. However, in Scratch, it's say. All right, so let's finish up by talking a little bit more about operators, because they're extremely important. Much of algorithmic thinking involves mathematical types of comparisons. And even in your create task, you are required to utilize mathematical comparisons and or logic in your algorithms. So we definitely want to understand these operators very well. And these are symbols that are similar to what you've seen in math, okay? Surely you have encountered these at the top. This up here is, again, pulled straight from the reference sheet, and they will give you this. So just in case you forget which way the alligator mouth opens for greater than, you can be reminded. I would like to just draw your attention real quickly to the term that they give to this section. They call this term relational and Boolean operators. All right, so there's the keyword operators, so just key in on that. But also, relational means how does one variable, in this case A, relate to B. So these are our relational operators, and this is how you will see it on the AP exam. If you see operators, they will look like this, okay? However, if you are writing text-based code, this one in particular, right here, is not able to be typed in plain text. All right, when you're coding and you're writing text-based code, you have to code in plain text. You cannot use special characters. And you know that that character, that equal sign with the line through it, you know that that is not a character that you can type in plain text. You would have to use a special menu to insert that special character. And we can't do that in text. So in text-based coding, you will actually see more of these down here. So this table right here is showing you what you would see if you're writing text-based code. All right, right here, a single equals symbol is actually used to assign a value to a variable. All right, but if you want to compare a variable to another variable or to a number, you need to use the double equal sign. And that's in many programming languages. Now, we said when you're text-based coding, you can't insert special characters like the not equals symbol. So to get around that, what we do, just like how we can't use an X for multiplication, we do use two characters, but they are characters that can be typed in plain text. And so you might see something like this with this exclamation point and an equal sign. A lot of times in text-based programming, an exclamation point means not. Okay? And I'm going to emphasize the word not, because I'm going to come back to that in just a second. All right, and then surely you recognize the greater than, the less than. And then we have this situation right here. Again, we can't insert this special character, okay? These special characters that we saw, we can't use those in text-based coding, so we just use both characters in sequence. So right here, you can see that we've got the greater than followed by the equal sign. That operator means greater than or equal to. All right, and right down here we have less than or equal to. And then I'm going to go up here and circle this not again, because that brings me right back to what I pointed out to you at the top of the page here, which is that word right there, Boolean. Okay, Boolean operators. That's why greater than or equal to is a Boolean operator, because there are two conditions and either one or the other can be true to set up that condition. All right, so in Scratch, pretty much the same thing. I just put in an example of not, because we wouldn't use an exclamation point in Scratch. We would actually use the not Boolean operator, and we would actually nest two Boolean operators together. We will talk more about this concept of nesting in a future lesson, but for right now, just know that we can put two operators together and to form a new meaning based on those two nested operators. All right, and then right here, if we follow the example from our voting condition, which was that you had to be greater than or equal to 18. And so this is how you would set that up. So if age is greater than 18, or if age is equal to 18, then you would display, great, you can vote, or something like that. All right, so that should give you a pretty good understanding of selection, and in the upcoming lesson, you will get a chance to apply this.
Hi everyone, my name is Mr. Levin, and I'll be one of your computer science instructors for this year's Computer Science Principles course. My name is spelled L-E-V-I-N and pronounced Levin, kind of like living the dream is one way that I've often told my students they can remember it. I myself have worked as a software developer, and now I'm a computer science teacher because I think learning computer science skills is so important and valuable that everyone should have the chance to learn them. So we're going to be going through the course together. You'll see me popping in different units to help you tackle different concepts as they come up in your course of becoming a young computer scientist. In today's lesson, the first topic that I'm going to help you with is called selection. So selection is basically when a computer encounters a decision, it has to select a choice from a set of options. And the way that you teach a computer to do that is by writing what are called if statements. Humans are really good at making decisions. You make decisions every day. You decide what pair of shoes to put on. You decide how you're going to get to school. Maybe you decide what you're going to eat for lunch. You can make those decisions often without even thinking about it. But computers, they're not very good at thinking for themselves. You need to help them make decisions by giving them really specific instructions in the form of code. So let's jump into this lesson and see how you're going to do that. Now that you have seen the relational operators that you can use to compare numbers, things like equals and less than, you're now going to be introduced to the Boolean operators, not, and or. So the first example from the reference guide is the not operator, and the not operator takes a single condition and it flips the value. So if this condition is true, then not will evaluate the whole thing to false, and if the condition is false, then not would evaluate the whole thing to true. So in this example here, we're checking if x equals 10, and we say if not x equals 10, then tell the user that's incorrect. Our next conditional is the AND operator. The AND operator takes two conditions, and it evaluates to true if and only if both condition 1 and condition 2 are true. So if condition 1 and condition 2 are true, then the whole thing evaluates to true. Otherwise, it evaluates to false. So here, our example from scratch down here is if y equals 15 and x equals 25, then they got both correct. So that means that both of them are true. Our last Boolean operator is the OR operator. So the OR operator also takes two conditions, but in this case, this OR statement evaluates to true if condition 1 is true, or if condition 2 is true, or if both of them are true. The only way that this is false is if condition 1 and condition 2 are both false. So here, we can use the OR operator to actually check if x is within a specific range. So here we say if x is less than 0 or x is greater than 100, then we say that's an invalid input, right? Because we're looking for the person to put in a number that is between 0 and 100. So if it's less than 0 or greater than 100, we know that it's not within that range. You could also rewrite this as an AND statement if you wanted to. Which brings me to my last point here, which is down here at the bottom, we actually have two different versions of a similar algorithm. Two different ways of writing code that has the same results. And you can actually write these both in Scratch and then compare how they work to confirm that they are in fact the same. And so the reason that I have this example here is to demonstrate that some conditional statements, like this one on the left, can actually be rewritten as Boolean expressions. And then inversely, some Boolean expressions can also be rewritten as conditional statements. They achieve the same results within the program. It's more of a question of which one you find easier to debug, easier to work with, or which one is easier to read, right? If you're actually building a compound Boolean expression and it ends up being longer than the screen is wide because you have so many or and not statements in there, then it might be better to break it up into multiple conditions. Alternatively, you could have the same problem if you have 10 if statements within each other. It sort of depends on your personal style as a programmer, and that's a choice that you will become more and more comfortable making as you practice writing more programs.